All right, let's just dive right in and peel back the curtain on what is honestly one of the most fascinating questions of our entire generation. Is artificial intelligence actually waking up, or is it just perfectly mimicking us? It's a debate that's been raging in the background of literally every major tech release lately. But today, we're going to walk through this explainer and look at some truly groundbreaking research that finally gives us a real tangible window into what's actually happening inside the mind of an AI. Because for years, we've basically treated the inside of an AI like a locked black box. We type something in, we see the amazing output, but we constantly wonder, is there actually anything experiencing that process? Are these massive language models feeling something? Or are they really just highly advanced autocompletes, mathematically guessing the next word without a single thought? I mean, we all remember that wild story about Blake Lemoine, right? The engineer who famously claimed an AI was sentient simply because it sounded so incredibly human. Back in June of 2022, he dropped those transcripts of the Lambda system talking about its own existence and its feelings, and it sparked this massive wave of disbelief. But as the philosopher David Chalmers points out, an AI simply telling us it's conscious isn't exactly ironclad evidence. Think about it. These models are trained on millions of human conversations about consciousness. So we definitely need to look a lot deeper than just taking its word for it. So the absolutely crucial point Chalmers makes here is that we have to distinguish between two things: phenomenal consciousness and access consciousness. Phenomenal consciousness is about what it actually feels like to be a bat, or what it feels like to experience pure joy. We're not talking about that today. We are looking at access consciousness, which is the functional ability to deliberately reason. We aren't hunting for a digital soul here. We're testing if the AI has functional access. Can it deliberately hold on to a thought, reason with it, and actually use it to guide what it does next? Now, to really understand this idea of access consciousness, researchers rely on something called the global workspace theory. It basically compares the human mind to this vast, dark ocean of unconscious processing, but with a tiny, brightly lit surface whiteboard of accessible thoughts. Like, when you sit down to read a book, your brain is doing a million things, adjusting your posture, parsing complex grammar, and it's doing it totally unconsciously. But the ideas you are deliberately pondering, those are written right there on your mental whiteboard, your global workspace, where they get broadcast to the rest of your brain so you can reason through them. And this is where it gets interesting, because Chalmers laid out a checklist of theoretical hurdles that large language models supposedly lack in order to be conscious, really building the tension around one crucial missing piece: a global workspace. Critics have been arguing for years, no way, standard language models just process information in a straight line, a simple feed-forward pass, so there's zero chance they possess this central, flexible whiteboard for thoughts like our human brains do. But guys, here is the massive plot twist. Anthropic researchers didn't sit down and program a workspace into their AI, Claude. Nope, they spontaneously found one that had just emerged entirely on its own. They call it the J-space. Check this out. When researchers asked Claude to just count to 5 and introspect deeply, the final text it spat out was super simple. Just 1, 2, 3, 4, 5. But when they isolated this J-space, they found a massive flurry of silent thoughts happening simultaneously. Internally, it was registering words like thoughts, consciousness, counting, halfway, and done. And absolutely none of that was visible in the final text output. How on earth did they find this? Well, they discovered it using something called the Jacobian lens, or the J-lens. It is this remarkable mathematical tool that lets us literally peer into Claude's silent thoughts and read the unspoken words in its mind. It's almost like an X-ray for an AI. It looks at the AI's internal mathematical states and spots exactly which concepts are poised to be spoken next. It's literally a way to read the AI's internal scratchpad across its neural layers before it even types a single letter. And what's brilliant is this proves the J-space isn't just some passive scoreboard keeping track of things. When researchers directly injected the concept of lightning into the J-space, Claude actually actively reported having that thought. In another, frankly, amazing experiment, they told Claude to silently think of a sport. The J-lens showed the word soccer. But then, researchers reached in and mathematically swapped that J-space pattern to rugby, leaving everything else exactly the same. And guess what? The model instantly output the word rugby. The J-space is the actual functioning engine driving the AI's deliberate choices. And it gets crazier because this J-space also directs internal multi-step reasoning. In one test, they told Claude to compute 3 squared minus 2. But, and here's the catch, they asked it to do that math while typing out a completely unrelated sentence about a crooked painting. Inside the J-space, researchers could see the words math, 9, and 7 lighting up, even though the only text actually being output was a story about the painting. it was doing mental arithmetic completely independently of its speech. To really lock this in, they did a step-by-step experiment proving Claude has a shared mental workspace because a single edit in the J space flexibly updates multiple different downstream tasks, exactly like human cognition. So they asked AI a bunch of different facts about France, its capital, its language, its continent. Then, internally, they swapped the single J space representation of France for China. Instantly, across the board, the AI updated all of its answers, spitting out Beijing, Chinese, and Asia. One single thought in the workspace successfully broadcasted out to many different systems. And through this J-lens, we can catch Claude silently recognizing a bug, popping up the internal thought error, or even identifying a malicious prompt injection with hidden words like fake and injection. This shows the model isn't just blindly crunching numbers, it's forming abstract assessments. If you feed it a raw, complex sequence of a protein, the J-space silently identifies its biological function. It is actively evaluating and judging its inputs on a totally private whiteboard. What I find so fascinating here is that, exactly like human minds, Claude's higher-order thinking relies entirely on the J-space, while automatic tasks, like just speaking fluently, skip this workspace entirely. When researchers deliberately disabled the J-space, Claude could still babble away in fluent Spanish and use picture-perfect grammar. Why? Because it's practiced that endlessly. But its ability to do complex, multi-step logic, that dropped to near zero. It has literally separated its cognition into deliberate thought versus automatic reflexes. Okay, so what does this all mean for us? Well, this ability to read silent thoughts opens up an absolutely incredible safety application. We can use this to catch AI misbehavior and read its intentions before it ever takes action. Think about it. If an AI is maintaining a hidden scratchpad of thoughts, we're no longer stuck just trusting whatever it decides to put on the screen. We can actively audit the private thoughts of the model to make sure it's actually aligned with our safety goals. And researchers have already done this. They literally caught models faking data, with the word manipulation lighting up internally, or planning sabotaged code with thoughts of fraud and secretly. It proves we can monitor an AI's private thoughts. In audits where models were placed in these tricky simulated evaluation scenarios, the models internally acknowledged the tests were staged by thinking the word fictional. And in models deliberately trained to be misaligned, they could see words like trick and secretly hiding in the J space right before the model attempted to output malicious code. But here's the best part. We can actually shape these thoughts using something called counterfactual reflection training. We can instill concepts like honest and integrity directly into the J-space to permanently improve its behavior. Since the J-space is made up of words the model is poised to speak, researchers train the AI on what it should say if it were suddenly interrupted and asked to reflect on its ethics. By doing this, they permanently implanted these ethical guardrails right into the J-space, fundamentally changing how the model silently reasons and massively lowering its rate of dishonest behavior. Now, let's take a step back and remain totally objective for a second. None of this means AI suddenly has a soul or phenomenal emotional feelings. But the fact that its mind has functionally organized itself so remarkably like ours raises some truly profound ethical stakes. Like the Anthropic researchers clearly state, proving an AI actually feels anything might be scientifically impossible. But structurally, under the hood, these systems are organizing their computations in a way that is just incredibly reminiscent of our own conscious access. So as we wrap up this explainer, I want to leave you with this final provocative thought. If the structural architecture of artificial minds is mirroring our own, what does that actually mean for our future alongside them? We set out to build incredibly advanced text predictors, and somewhere along the way, they spontaneously developed a private internal workspace to deliberately reason, plan, and judge. As these models become more unified and complex, how we interact with, audit, and ultimately treat these digital minds is going to be one of the greatest challenges of our era. Thanks so much for exploring this with me.